In this exercise, we're trying to determine whether the relation shown below between x and y represents y as a function of x. And in order to do this, what we want to do is we want to use algebra to move the numbers and the variables around so that y is on the left-hand side of the equation and an expression with only x and numbers is on the right-hand side. So we solve for y, which means we want y on the left-hand side and x with a bunch of numbers on the right-hand side. So I am first going to cross multiply. Well, if you don't know what that is, what I'm doing is I'm taking x equals 3y plus 5 and divide by 7y minus 7, and I'm multiplying both sides by 7y minus 1. I might have said something wrong when I said that, but it's 3y plus 5 divided by 7y minus 1. I multiply both sides by 7y minus 1. So therefore, I'll have 7y minus 1 times x equals, and then we see there's canceling. 3y plus 5 is what's on the right-hand side. So usually I would do that without showing that work that I showed in green. I would cross multiply. Now, I multiply x through distributive property, and I get 7xy minus x equals 3y plus 5. Now, add and subtract to move everything that has y to the left-hand side. And we're going to move everything that doesn't have y, that has x and numbers without y, to the right-hand side. LHS is my shorthand for left-hand side. So we have 7xy, that's already in the left-hand side. I want to bring this minus this 3y to the left-hand side, so I subtract both sides. Minus 3y. On the other hand, I want to bring this x to the right-hand side, so I add x. I usually don't write those little things there that I wrote down below, and the reason is I think it's messy. But anyway, and so I usually don't write those little notes of subtracting and adding. All right, so now see we have two terms and they have y's. What we're going to do is factor out y. And everything would go faster if I didn't write all these little notes here. And then finally, we divide. And what we're really doing here is we're using the order of operations, and we do them backwards. Okay, again, what I'm going to do is maybe show more work than I usually would. But, okay, I'm going to divide by 7x minus 3 on both sides. And because of that, we see there's canceling. And therefore, we have solved for y. And by doing that, what this shows us is that for each value of x in the domain, there is exactly one value of y. And that's what describes a function. If for each x, there is only one y in the range. So, yes, y is a function of x because the formula shows that for each x there in the domain, maybe I'll leave that off. Each x there is exactly 1y. What I mean to say is each x value, there is exactly one y value. Okay, I'll zoom out so we can look at that in total. See if it comes into it. So this is Openstax Precalculus 1.1, number 15. And maybe I can highlight the final answers here. Yes, y is a function of x, and that's our final answer. Okay, and really because y can be written as a function of x. All right, that's the end of this video.